Hello everyone, welcome to another Leetcode problem discussion. Today we're going to discuss problem 79, word search. We're going to discuss the problem, talk about the solution technique, and then code it up. So this is one of the popular problems, and this is one of the problems within the blind 75 list. So the problem description says that given a m into n grid of characters, that means m rows and n columns, and a string word, we have to return true if the word exists in the grid. So the word can be constructed from letters sequentially at letters of sequentially adjacent cells, where the adjacent cells are horizontally or vertically neighboring. So suppose we can start building a letter word this way, EC, or we can start building a letter this way. So anyway, you can go to left, right, top and bottom. The same letter cell may not be used once. So if someone says, so if I start a word from here, say S, F, then I cannot again come back to S. Okay, so I cannot reuse any letter. So in the first example, you see we are given this character board, which you can think as a 2D array, right, or a matrix, and then we are given a word A, B, C, C, E, D. So you can see A, B, C, C, E, D can be built in this board. So that we return true for that. In the second, in the next example here, you see we are given the same board. Now the given word is A, B, C, B. But you see we have A, B, C, but we actually cannot come back here, right? So we cannot reuse any character. So that's why ABCB is not found. We cannot find ABCB anywhere, right? Because we cannot reuse character. It's not like this. We cannot do that. So one question that you may ask the interviewer before the interview, one good question is like, what kind of characters are here in the board? Like, are they uppercase or lowercase characters, or they can be mixed? The reason behind that is, say, if they're like mix of them, yeah, like suppose this one was something like lowercase. In that case, is that going to be replacement for E? If the interviewer says, well, uppercase and lowercase letters are different, in that case, this is not a replacement for uppercase E. Otherwise, you can just use it. So that's one good question you may ask. Now let's talk about the solution technique. So say my word here is CEDF. Okay, so this is my word. Now think how you can try to find this word or try to build this word in the character grid. So the input character grid is something like you're given like this A, B, C, E, right? And then SF, CS, and then ADEE. So you're given this, and now you have to try to build this word. One thing to notice here is this one doesn't have a very smart way to solve it. I think the first thought that comes into everyone's mind is trying to build this word in a brute force manner. And actually that is the way you have to do it. So you can think this like a graph. And if this is like a graph, and from every cell you can move in 4 directions, right? You can move in 4 directions. So we can actually start from from every grid cell, and try to expand and see if I can start building the word and keep on matching. So for example, if I start from here, right, you see this one doesn't match with C. It doesn't match with C. So that means starting from here doesn't work. Similarly, we'll try to start from here. It won't work. And then we'll try to, so basically you are doing some kind of DFS and you are trying to traverse this graph from trying to do it from every cell. And then once we do this, you see, once we do this, now this time, sorry, once you're trying to do this time actually C matches, right? So you are done. You're successful in matching. So next, what you have to do is you have to try in all 4 directions. Now you see this one is out of bound. So after I move to a new state, I have to check the boundary. Then I also have to check the character. So that means once I move in all these 4 directions, I have to I have to keep a track of that which character I'm trying to match. So I will try to match character 0 from here, right? And then I will try to match character 1 here. So this is the depth of your DFS, right? So character 1, and you see this one is ruled out, and then this DFS is also ruled out. The reason behind that is like you see the character 1 here doesn't match, right? So that is also ruled out. That branch is ruled out. This is also ruled out for the same reason. Now this one is successful. This is successful, right? Okay. So what we can do is now next, I will move further in all 4 directions. Okay, so here is one thing. If I try to move from all 4 directions from here, okay, obviously this is ruled out. This will be ruled out because these are outside the boundary. This one we cannot do this one because we cannot reuse any character. So how do I make sure that I can't reuse? One way to do that is like mark this character as visited, right? So a simple way to do that can be like in the code that I'm going to do is I'm just going to replace this temporarily with another character, say something like this. So you can ask your interviewer like what characters are not valid characters. So you can replace it with the invalid character. So what happens now is if you try to go in all 4 directions, these 2 are ruled out. Now here, once you come this direction, you see that we are now trying to match character 2, right? So we'll keep track of how deep we are. So everywhere we are trying to match character 2. Character 2 obviously won't match here. And then even here, it won't get matched. So we are done, right? That means the one that we tried from here, it went to E, and then after that, it couldn't go anywhere. So that means we are done. So what we have to do is we have to backtrack the same place and replace this grid with its actual character. Okay. Okay, so we keep on doing this, and then you see once we reach here, we go in all 4 directions. We start with character 0. So suppose we start DFS here, everything failed. Then we started DFS from this cell, tried to match character 0 matched. Okay, and then we go in all 4 directions. Here it fails, right? So everywhere I'm trying to match character 1, right? So this one matched. Okay, so from here, Again, we'll try to go in all 4 directions, but this one will be temporarily replaced by an invalid character. So this one is going to fail. So we are making sure that we're not visiting here. So then, and everywhere we are actually trying to find character 2, right? So character 2, we're trying to find, and also here. So this one fails, this fails, but this one succeeds. You see, this one succeeds, right? This one succeeds. So we also mark it with an invalid character. And then from here, we can next go to here, try to find character 3. This one will also succeed, right? So that means we have found our way. We have found this thing, right? Okay. And once I found this, we are done, because we have to we don't have to find all possible word builds. Just once we are done, then we're fine. So what is the complexity of this algorithm? So if you think carefully, say suppose here, from this node. Okay, so from every node, we can actually go in 4 directions. So this is C. From here, we can go to, say, F. We can go to S. We can try to go to C, right? And then we can try to go to E. Okay. Okay. Now you see, these branches are actually going to fail. These branches are going to fail. From E, we can actually go down further. So from E, we can go to, again, we can go to E. So this E, right? And then we can go to D. So this one will be a mismatch. So we don't go further down there. From D, we can go to A, right? Then we can go to F. We cannot go back to E because E is already visited, right? So it will be transformed like this. So we can, this won't happen because this is already visited, right? This is already visited. And this is already replaced by this. Okay. So, and this one also will be a failure because the character mismatch. So here is level 0, this is level 1, this is level 2, this is level 3, right? This is level 3. But the third character here is a mismatch here. So this is failing, but this is a success. Okay, so if we think like this, we see that if the length of the word is L, our tree goes L deep. The DFS goes at the depth of L at most. And so the space complexity is going to be order of L. That one we know that the call stack is going to be L length. And this time complexity is going to be, you see, we will actually, in the worst case, what's going to happen is we are going to try in every node, right? So if there are, suppose, n nodes or n grid cells, and from everywhere, if I do DFS, you see how many nodes we visit. So in every level, there are L levels. In every level, we at most visit, say, four nodes, because there are like 4 neighbors, or it's like 3 nodes. Yeah. So in the first level, we can visit four nodes here. In the second level, at most, we will visit 3 nodes. In the third level, we will also at most visit 3 nodes. So there are like L levels, and let's say take the upper bound. So in each level, I can visit 4 nodes, and the total number of nodes that are going to visit with L depth is going to be 4 to the power L. So we will be doing, so every DFS is going to take like visit at most these number of nodes, and there are like n nodes. So the total complexity, time complexity is going to be order of n into 4 to the power L. Okay, let's try to code this thing. Okay, so this is a backtracking algorithm. As you see, if we fail somewhere, we backtrack again. So for that, let's write the DFS function. So in the DFS function, we have to add some extra. So we need the board every time, we need the word every time for the matching, and then we have to pass the row and column, and also the depth, how deep we have gone so far, right? Okay, and then the first thing that we need to do is we have to check if the row and column is within the bounds. If it's out of bounds, then we have to return false. So this method is going to return Boolean, true or false. Okay, so if any of this is true, then we return false because this is out of bound. Or if the current character in the board, that is in the cell, in this cell, in the row column cell, is not equals to the character in the word at position of depth, right? If that is the case, then we return false. Okay. If that is not the case, that means the character at depth matches this character cell, right? Character in this cell. In that case, we have to check if we have reached the end of the word. So how do we do that? So we can just say, check if my depth is already equals to word dot length -1, right? If that is the case, that means character has matched and this is the last character. Return true. Okay. Otherwise, it means that we have reached a valid character, but we are still not done. So we are somewhere in the middle, searching for. So we have to search for more characters. So what we do is we first have to change the current cell value temporarily. So let's put it in a temp. We put it in a temp and then change it to an invalid character. We have to put it in a temp because once we backtrack and come back to this cell again, we have to restore the character. And then we go in all 4 directions. We'll call DFS with board word. Say we'll go to the right, so we'll go down, so we increase the row by 1 column, and depth also goes by we add 1 to the depth, so because we'll be searching for the next character, right? Next character in the word. So we have to do this like in all 4 directions. So the next direction is going to be, let's copy this. So here I will go up. Okay, here I will go right. And here I'm going to go left. So if any of these is true, I return true, right? So I need just a successful search in any direction. And then we have to restore. So after I'm done with this, I have to restore my character. So character at the current position. And I return the result. Okay. Okay, so that is okay. So once I start DFS, once I start DFS, this will return the result whether I have a match or not. Next, what I have to do is I have to do it like from each cell, right? So I want to do it from each cell. Okay, so we call DFS. I start with row I and column J, and I start with the first character, that is 0th character in the word. If I find a match, I can just return true immediately because I don't need to find all matches. Otherwise, I will just go and try the next cell. Okay, so let's try to run this. There must be some typos or something. Okay. Okay, so otherwise we return false, right? If there is no match even after I try everything, then I do submit. Okay, so this one is a pretty fast one. You see, you beat 82% of the previous submissions. So hopefully you understood this problem and understood the solution technique. This same solution technique is going to be used in many other backtracking problems. So till next time, thank you for watching and see you next time in another problem discussion of another problem.